Welcome to Spring LIB.
The first thing to note about this problem is that I made A negative instead of positive because it opposes the motion that you have originally, this V naught here. Another thing to notice is that the units on the V naught do not agree with the units on the A. So I'm going to convert the units on the V naught. So V naught is 105 kilometers per hour. I'm going to multiply this by a conversion factor. First, I'm going to change the kilometers into meters. Now in 1 kilometer, there's 1,000 meters. So that's that conversion. And the kilometers cancels. I also need to convert the hours. So hours goes up here into seconds. 1 hour is 3,600 seconds. And then the hours cancel. The result of this is 29.2 meters per second. And now we can actually proceed with the problem. In this problem, we want to calculate x minus x naught. We want this. And we're going to calculate using the threshold acceleration so that we know a threshold distance needed. And then if we go below that, we know we're in trouble. We have to go above this threshold distance. But it's nice to have the threshold distance. And what we're going to do to calculate it is use the kinematic equation. V is equal to V naught squared plus 2a x minus x naught. I use this one because we have no information about the time, and this is the one kinematic equation that doesn't involve time. I'm going to calculate on the next page. Just shifting things around to solve for x minus x naught, I get this expression. And then now I'm going to plug in values that we have. So x minus x naught is equal to 0, since the final velocity after the airbag has stopped us is 0. And the initial velocity, the initial velocity squared, which is 852.64 over 2 times the acceleration, negative 250. This ends up being 1.71 meters. And so if you move less than 1.71 meters, then you're in trouble. But if you're moving over 1.71 or 1.71 meters during this interaction, then you're going to be okay. And that's the conclusion of this problem. That's the answer.